Bismillahirrahmanirrahim. We will start today, continue the lesson 2, problems on lesson 2. Okay? Problem number 6. A wire of cross-sectional area 10 to power negative 6 meter square. A equal 10 to power negative 6 meter square area. Material resistivity, electric resistivity 10 to power negative 7 ohm meter. Is coiled in form of circular coil. Okay, circular coil of radius 7 over 22 meter. Radius equal 7 over 22 meter. And the number of turns N equal 100 turns. Okay. The terminals of the wire are connected to an electric source, so potential difference V equal 50 volt. Calculate the electric current. We want to calculate electric current intensity. To calculate electric current, and we have volt, we must calculate resistance. Okay? How calculate resistance? Resistance, and we have resistivity. Resistance R equal rho EL divide A. We have area, we have resistivity, but not length. Length we can calculate from radius of coil and the number of turns. How we take last lesson, length of wire equal 2 pi R perimeter of coil times a number of turns, so equal 2 times 22 divide 7, this is by, or 3.14, or by calculator, times a radius 7 over 22 times 100 turns. We cancel them, equal 200 meters, the length. So now we can calculate resistance. How? Resistance equal rho 10 to power negative 7 times 200 meter divide area 10 to power negative 6. By calculator, we can calculate resistance equal 20 ohm. So V equal R times I. V 50 equal 20 resistance time I. I equal 2.5 ampere. It's easy. Okay? Okay. The next one. A copper wire of length 50 centimeter. Length equal 50 centimeter. Okay? Times 10 to power negative 2 to convert it to meter equal length equal 0.5 meter. Material density, rho density 8600 kilogram per meter cube, carries an electric current. So it has a resistance, we have resistance R 1.5 ohm. Calculate the mass of wire. We want to calculate mass. And we have electric resistivity 1.79 times 10 to power negative 8 ohm times meter. How? Okay. To calculate mass, and we have density, we must calculate volume. Okay. To calculate volume, we have length. So we must calculate area. Because this wire, we deal wire as a cylinder. V volume equal cross-sectional area times the length. Okay. So area equal volume على length. Okay. And we know rho equal mass divide volume. So volume equal mass على divide rho. We take this, substitute here. Area equal M divide rho L. since resistance equal rho E L divide A, we take A, so R equal rho E L divide M divide rho L, so equal rho E L square rho divide M. What is the amount of resistance? 1.5, okay? 1.5 equal rho E 1.79 times 10 to the power negative 8 times L 0.5 square times density 8600 divide الماss. So by calculator we can find mass equal 2.57 times 10 to the power negative 5 kilogram. Good. Another problem. A wire of length 30 meter, length equal 30 meter. Cross sectional area A equal 0.5 centimeter square times 10 to the power negative 4 meter square, and resistance R equal 20 ohm. What is the resistance of another wire? Another wire, so we labeled them 1, 1, 1, L1, A1, R1. That is made of same material. Same material mean same electric resistivity, and has length L2 equal 10 meter and area 2 equal 0.3 times 10 to the power negative 4 meter square. We must calculate R2. Since two wires same materials, so resistivity of first wire must equal resistivity of second wire. So R1 A1 divide L1 equal R2 A2 divide L2. Substitute R1 20 times A1 0.5 times 10 to the power negative 4, L1 30 equal R2 unknown, A2 0.3 times 10 to the power negative 4, L2 10. By calculator R2 equal 1.11 ohm. Okay? Okay. Good. Another problem. Another problem, okay. Two copper wires, take care, two copper wires, so both of wires made of same material, so rho E1 equal rho E2, okay. The length of one of them is 10 centimeter, L1 equal 10 centimeter, so 0.1 meter, and its mass M1 equal 0.1 kilogram, and the length of the other L2 0.4 meter, M2 equal 0.2 kilogram. Compare between their resistances of each of them. We want to calculate R1 divide R2 ratio, compare. Okay, we start solve by this information. Rho E1 equal rho E2, okay? Resistance equal by from last problem, this problem, okay? Resistance equal rho E L square rho على M. Okay? Okay. Then rho E equal RM divide L square في density times density. Apply this in this equation. R1 M1 L1 square rho equal R2 M2 divide L2 square rho. Same material, same density. Substitute R1. We want to calculate R1 divide R2. So R1 divide R2 equal M2, okay, L1 square M1 L2 square. Substitute M1 M2 M2 0.2 times 0.1 square divide 0.1 times 0.4 square equal by calculator 1/8. Okay, good. Another problem. Two wires have the same length, L1 equal L2. One of copper and the other of iron. So L copper equal L iron. And both of them are carrying the same current. I copper equal I iron. When the same voltage is applied, so V copper equal V iron is applied across of them. Calculate the ratio between their radii. We want to calculate radius of copper over radius of iron. And we have resistivity of iron and copper. Okay. How we can solve it? To calculate it, we must start by Ohm's law because we have current and volt. Since I copper equal I iron and V copper equal V iron and Ohm's law V equal Ri, so R copper must equal R iron. Okay. The resistance R equal rho L divide A and A by R square. Then R copper rho E copper times length copper divide by R copper square equal rho E iron length of iron divide by R iron square by okay, and the length of copper iron equal we get rho E copper divide R copper square equal rho E iron divide R iron square. So okay, and this here, okay, this here, okay, we get R copper square divide R iron square equal rho E copper divide rho E iron. Okay, take root square R copper divide R iron equal root square for these values. These values from given rho copper 1.7 times 10 to the power negative 8 divide 8.7 times 10 negative 8 by calculator 0.42. Good. Okay. Next problem. A wire of resistance R equal 5 ohm is stretched, so its length is increased to double. Okay, there is another wire. This the first wire is stretched to become this. So this R1 5 ohm, L2 equal to L1. Calculate the wire resistance after stretched. We want to calculate R2. Since R equal rho L divide A. Okay. So R1 equal rho E, same material because the same wire. L1 divide A1. A will change it because wire here is more thick than in this case. R2 equal rho 2 L2 divide A2. Okay. As we know from laws before, in this case, R1 divide R2 equal L1 square divide L2 square. So R1 5 divide R2 equal L1 square divide L2 b2 L1 2 L1 square. 5 divide R2 equal L1 square divide 4 L1 square. L1 R2 equal 20 ohm by calculator. Okay. Okay. Another problem. Two wires are made of different material. So we have rho E1 and rho E2. The length of the first is 3 times that of the second. L1 equal 3 L2. And the radius of first is 1/3. R1 equal 1/3 R2. If the two wires have the same resistance, R1 equal R2. Calculate the ratio between their resistivity. We want to calculate RE1 divide rho E2. Okay. As we know, rho equal RA divide L, or R by R square divide L. So rho E1 equal R1 by R1 square divide L1, and rho E2 equal R2 by R2 square divide L2. Divide them, rho E1 divide rho E2 equal R1 by R1 square divide L1, and rho E2 R2 by R2 square L2. Okay, both of them have the same resistance. Okay, we have R1 square L2 equal divide L1 R2 square. Okay, R1 equal 1/3. 1/3 R2 square L2 divide L2 equal 3 L2. 3 L2 times R2 square equal 1/9 R2 square L2 divide 3 L2 R2 square. Okay, equal 1/27. Okay. This is the end of problems. Before close this lesson, we must know that some important notes. Electric power. Simple BW equal IV or I square R or V square divide R or work or energy per time. The unit of this is watt or W, watt. Electric energy, W equal power, electric power times time, or equal IVT, or equal I square RT, or equal V square T divide R. The unit of electric energy, joule. Okay? Okay. Good luck and see you in the next lesson. Okay.